Introduction. Start with a brief explanation of what projectile motion is. The motion of an object thrown or projected into the air, subject only to the force of gravity and air resistance if applicable. Mention the significance of projectile motion in various real-life scenarios such as sports, engineering, and physics experiments. Basic concepts. Define key terms such as initial velocity, horizontal velocity, vertical velocity, acceleration due to gravity, range, and maximum height. Introduce the two components of projectile motion: horizontal motion, constant velocity, and vertical motion, constant acceleration due to gravity. Equations of motion. Discuss the equations that govern projectile motion. Horizontal motion. Horizontal. Distance equals horizontal velocity time. Distance equals horizontal velocity time. Vertical motion. Vertical displacement equals initial vertical velocity time plus 1 to acceleration due to gravity time to vertical displacement equals initial vertical velocity time plus 1 acceleration due to gravity time 2. Example problems. Provide examples to illustrate how to apply the equations of motion to solve projectile motion problems. Example 1. A ball is thrown horizontally from the top of a building with an initial velocity of 15 meters per second. Calculate the time it takes for the ball to reach the ground. Example 2. A projectile is launched from the ground with an initial velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Determine the maximum height reached and the horizontal range. Graphical representation. Show graphs depicting the horizontal and vertical motions of a projectile over time. Explain how to interpret these graphs to analyze the motion of the projectile. Real-life applications. Discuss real-world applications of projectile motion in fields such as sports, for example, basketball, soccer, engineering, for example, missile trajectory, and physics experiments, for example, motion of celestial bodies. Conclusion. Summarizes key concepts covered in the lecture. Emphasize the importance of understanding projectile motion in various contexts. Visual aids, incorporations, diagrams, and real-life footage to enhance the visual appeal of the lecture. Use simulations or virtual experiments to demonstrate projectile motion in action. Engagement. Encourage viewers to attempt practice problems to reinforce their understanding of the concepts. Invite viewers to ask questions and participate in discussions in the comments section.